Hello and welcome to section 5.1, the product rule and the power for exponents. If you have not already, please pause this video and open section 5.1 of the text. Read the section and fill out this page 124 of your notes packet. Once you have completed that, please return to this video and continue. No, really, go do it. Okay, now that you've done that, let's move on to classroom practice 5.1, the product rule and the power for exponents. Learning objective 1, use exponents. This we have done before, but now we have variables involved. Doesn't change very much at all. How many 3's do I have? 3. How many x's do I have? 2. So this is 3 cubed times x squared. Which you could also write as 27x squared. Here we have negative 4 times m cubed times n squared, or negative 4m cubed n squared. And finally down here we have 5 squared x squared y squared z squared, which is 25x squared y squared z squared. All right, next we have the product rule. The product rule for exponents says that if you multiply and you have the same base down here, then you can add the exponents. And the reason for that is here I have 4 7's, here I have 3 7's. So if I wrote that all out and multiplied, I would just have 7 7's. So I can do it quicker by just adding those exponents. The same thing here, 1/2 to the 9th, 1/2 to the 1st. Multiply those, it's going to be 1/2 to the 10th. Just add 9 plus 1. Here, basically a rule for these is when you have numbers and you have letters, deal with them separately. So first I will do negative 2 times negative 4, that's 8. Then c to the 7 times c to the 8, you get c to the 7 plus 8, which is 8c to the 15th. And then the last one of these, 3 times negative 8 is negative 24, times negative 2 is 48. And then I have k to the 7 plus 2 plus 9, which is 48k to the 18th. Objective 3. Use the rule a to the m to the n is a to the mn. So the reason for this rule is, for example, if I have 7 cubed to the 4th, that means I have 7 cubed 4 times. And then if I added those exponents, I would just be doing 3 plus 3 plus 3 plus 3, or 3 4 times, which means I can multiply them. So 7 to the 12th. V to the 36th. Oh, but I need a negative sign because it's out front. 1/3 cubed to the 5th. That would be 1/3 to the 3 times 5, which is 1/3 to the 15th. You need to put parentheses on these fractions because otherwise it looks like you have 1 to the 15th over 3, which is not the same thing. Objective 4. Use the rule. A times b to the m is the same as a to the m, b to the m. So what this says is if I have a power on the outside, I can put that power in and just treat each of these things separately. So this would be 5 to the 4th, r cubed to the 4th, t squared to the fourth. Well, 5 to the fourth is 25 times 25 is 625. R cubed to the fourth, you multiply those, get r to the 12th. T squared to the fourth, multiply those, t to the 8th. Same thing here. Negative 2 to the fourth, w cubed to the fourth, z to the 7th to the fourth. Negative 2 to the fourth is negative 2 times negative 2 times negative 2 times negative 2, which is 16. W to the cubed, w to the third to the fourth, you multiply those, w to the 12th. Z to the 7th to the 4th, multiply those, z to the 28th. Next up, we have a very similar division rule. Remember, I'm a division denier, so this is really just the same rule. You just take everything to the third power. I don't think I would do all of these, but let's say this was negative 2 cubed x cubed over 5 cubed. That's negative 8x cubed over 125. Let's do one more. Fourth power, x to the fourth, y to the fourth, z squared to the fourth. You multiply those powers, get z to the 8th. Good enough. Objective 6, use combinations of the rules for exponents. So on these, we've got a lot of different things going on. Let's start with one of these. Negative x cubed squared. That would be negative x cubed squared. A good way to think about that is negative 1 x cubed squared, which means first we need to square negative 1, and then we need to square x cubed. And then we've got the same thing going on, negative 1 to the fourth, x to the fifth to the fourth, for the second number, or second term. So what you'd get here is 1 x to the 6th times 1 times x to the 20th. Well, that's 1, which I don't need to write down, and then you add the exponents and get x to the 26th. On this one, everything in here to the 5th power, that'd be 2 to the 5th, a to the 5th, b to the 10th, c to the 5th, right, because you multiply those, times a to the 4th, b to the 4th. Well, 2 to the 5th is 32. A to the 5th times a to the 4th, you add those exponents and get a to the 9th. B to the 10th times b to the 4th, you add those exponents and get b to the 14th. And then there's only one c, c to the 5th. The last problem here, number 18. Why can't b be 0? Oh, because we would divide by 0 and that'd be very bad. So these little notes like this are always really important in a math class. So I know it's going to be negative when I'm done. That's not part of the power though. So I'm just going to put a negative sign here. And then when I'm done, I know it's going to be there. But I have 2 to the 5th. A to the 3 times 5 is 15. C to the 5th. 5 to the 5th. B squared to the 5th is b to the 2 times 5 is b to the 10th. Well, that's negative 32, a to the 15th, c to the 5th, over 5 to the 5th, I believe, is 3,125. Yep, I'm pretty sure about that. And then b to the 10th. Okay. We have only one more objective left. And that is using these rules for exponents in geometry applications. So we'll just do one of these, I think. So they want us to find the area. Well, the only thing that you need for these is the area's length times width. Area is base times height. Area is 1/2 base times height. So it just comes down to here, multiplying these two. So you do 5m to the 4th times 2/5 m to the 6th. Well, 5 times 2/5 is 2. Right, the 5's cancel. And m to the 4th times n to the 6th is m to the 4 plus 6, which is 2m to the 10th. The other two are similar. Section 5.2, Integer Exponents and the Quotient Rule. Are you excited? I hear squeals of excitement. I am also very excited to do this section. Unfortunately, if you have not read and filled out this sheet, you need to pause the video and go do that and come back. So please go read section 5.2. Fill in this notes page. It's important that you get this part with all these rules down here. This is going to be important for you later. Have you done that? Okay. Well, instead of pausing, I'm just going to wait here for a half an hour while you do that. Okay, I did that, but I edited the time out, so we're going to keep going. 5.2. Use 0 as an exponent. One of the rules that you have on that sheet before you tells you what to do with 0 exponents. And basically the rule is that for anything that is not 0, because 0 to the 0 is complicated. Learn about that later. But anything else to the 0 is 1. Is 1. This is 1 plus 1, which is 2. This is negative 1. Right? Because the 0 makes that part 1, but then there's another negative sign, so it's negative 1. So one of our exponent rules is that anything to the 0 is 1. Well, anything that's not 0 to the 0. That's complicated. Use negative numbers as exponents. Well, here's how I remember this. An exponent tells me how many times to multiply something. A negative exponent kind of tells me how many times to divide something, or multiply by its reciprocal. So this means 1 over x times 1 over x times 1 over x, which is 1 over x cubed. But the simpler thing to remember is that this is x to the negative 3 over 1. If you cross this line, you change the sign. So if I want to make this positive, I just move it down here, which will leave a 1 behind and make that x cubed. So number 6, they want us to use only positive exponents. If I move this above the line, I change the sign, a to the 7th. Move this above the line and change the sign, r to the 7th. Negative 4 to the negative 4. Boy, they're just trying to be annoying on this problem, aren't they? Well, let's write this down for what it means. This is negative 1 over negative 4 to the 4th. Because this negative tells me if I move it downstairs, it'll become positive. So this is negative 1 over, and then negative 4 to the 4th, that would be multiply negative 4 times itself 4 times, which turns out to be 64. So this is negative 1 over 64. 3x over negative 2 minus 6 over x squared. Well, that's 3 over x squared, because if you move it down, you change the sign. Across the line, change the sign. Minus 6 over x squared. This is not something we've done before, but these have a common denominator, and if you subtract them, you have negative 3 over x squared, because 3 minus 6 is negative 3. This one, I can move both of them to make them positive. 2 to the negative fourth, I can move downstairs as 2 to the fourth, and 8 to the negative second, I can move upstairs as 8 to the second. So this is 64 over 2 times 2 times 2 times 2 is 16. That's the number 4. We will keep going. Use the quotient rule for exponents. The quotient rule says if you have a to the m over a to the n, it's a to the m minus n. It's just like the product rule. When you multiply, you add. Well, when you divide, you subtract. And again, the reason for that is you could rewrite the division as multiplying with a negative exponent, and then that would have you subtract. But we don't really need to concern ourselves too much with that. We can just use the rule as it is. So 12 to the negative 7 over 12 to the negative 6 will be 12 to the negative 7 minus negative 6. Well, that's 12 to the negative 7 plus 6, which is 12 to the negative 1, which is 1 over 12 to the 1, which is just 1 over 12, right? Because to change this, to change the sign, you cross the line. So I'm going to cross it down under the fraction bar, make it a regular 12. I'm supposed to write this with only positive exponents. Well, a to the 6th, move both of these down to change the sign. B squared c to the 4th. Let's do this one. Now you have a couple options with these. We can do the numbers and the letters separately. And then there's a couple ways to do this. So I could multiply these out and then reduce the fraction. I could also do the division rule as I see it. So 2 to the 4th minus 5 times x to the 2 minus 8, which will be 2 to the negative 1 times x to the negative 6. And then to write those as positive, I would have to cross them both below the line. 2 to the 1, which is just 2, x to the 6, because when you cross the line, you change the sign. Now another way to think about this that's really kind of cooler, you can leave them right where they are and just subtract and leave the bigger exponent where it was. So 5 minus 4 is 1, 2 to the 1. 8 minus 2 is 6. Leave it on the bottom. So then you don't have to go through that negative exponent change-a-roo. Let's do number 14. The 3 is going to stay where it is. This x to the negative 4th, I'm going to move to the bottom as x to the 4th. And then I'll do 3 minus negative 2, because I'm going to start with the bigger one. 3 minus negative 2 is 5. That's y to the 5th. The other way you could think about that is I'm going to move this y squared down here, and then y cubed times y squared is y to the 5th. You could also think about I'm going to do negative 2 minus 3, which is negative 5, and then I'll move the whole negative 5 down. There's a lot of ways to do these. They all work. Let's do number 15. 3 to the negative 1. It's 3 separate problems, really. So 3 to the negative 1 over 3 to the 4. So I could do 3 to the negative 1 minus 4, which is 3 to the negative 5, which means I need to write it as 1 over 3 to the 5th. M to the negative 4 over m to the negative 1. M to the negative 4 minus negative 1 is m to the negative 4 plus 1, which is m to the negative 3, which gives me m cubed on the bottom. And then p to the 6th over p to the negative 2 is going to give me p to the 6th minus negative 2, which is p to the 8th. And that would go on the top. Again, if you wanted to start with the bigger exponent and subtract and leave the answers where they are, you get 4 minus negative 1 is 5, would stay on the bottom. Negative 1 is bigger than negative 4, so negative 1 minus negative 4 would be positive 4. So negative 1 plus 4 is 3, leave it on the bottom. And then 6 minus negative 2 would be 8. Leave it on the top. Objective 4, which is our last page of notes for today. Using a combination of rules. So, starting with number 17, the very first thing, I cannot deal with these negative exponents. So let's get rid of them. I'm going to move each of these across the line to change the sign. So it's going to be 3y squared, 2y to the 4th. Well, that is 3 squared y squared over 2 to the 4th y to the 4th. And that is 9y squared over 16 y to the 4th. Done. 4 squared times 2 to the negative 3. Well, that would be 4 squared over 2 cubed. Cross the line, change the sign. That's 16 over 8. That's 2. Let's look at this one. We'll work on this term first. 2 p cubed, I'm going to move down to change the sign. Q squared is going to stay up there. Times, this whole thing needs to move down, right? Because it's all negative. So I'm going to move the whole thing downstairs. 4 p to the 4th, q to the negative 1. Well, I don't like that this q is negative. So to change it, I'm going to cross the line and change the sign and move it upstairs. So now let's rewrite this. This is 2q cubed over 4 p cubed times p to the 4th is p to the 3 plus 4 is p to the 7th. And then 2/4 is 1/2. So this becomes q cubed over 2 p to the 7th. Let's look at number 20. 9xy to the 7th. I do not like that negative exponent. I am going to move it downstairs. That makes the whole thing look like that. Well, here's the nice thing. This is the same thing. The same base, different exponents. So I can subtract the exponents. And I want to subtract them so that I leave it positive on the bottom here. So this is 1 over 9xy. Right? The other 7 of these cancel and I'm just left with 1. 9xy. Oh, number 21, what fun you are. First thing I see, I need to switch these. So I'm going to rewrite this as a cubed b squared times ab squared to the 6th over a to the negative 1, b to the negative 2 to the 4th. Now let's work all of these out where they sit. This would be a to the 6th, b squared using the product rule. This would be a to the 6th, b to the 12th using the product rule. And this would be a to the minus 4, b to the minus 8 using the product rule. Well, I don't like these negatives, so let me move them to the top. Now I have a to the 6th, b squared times a to the 6th times b to the 12th times a to the 4th times b to the 8th. Now I can multiply all these a's together and multiply all these b's together to get my final exponent values. So 6 plus 4 is 16. Again, using the product rule that you add the exponents when you multiply. And then b, 2 plus 12 plus 8 is 22. A to the 16, b to the 22. The last one we have, there are multiple ways to do this. One thing that I could do is I could immediately try to flip this over. If I were to take the negative sign in, I could flip the whole fraction over. But I think it's probably better to use the product rule first and multiply minus 4 times all these exponents. So that's going to give me k to the minus 12, t to the minus 16, k to the minus 8, t to the 4th. Now again, I could move these all around right now. That would totally work. I think I'm going to go ahead and just do my subtraction. I'm going to do my bigger one minus my smaller one in all the cases. So negative 8 minus negative 12. That's negative 8 plus 12. That's a 4. And it's going to stay on the bottom because that's where I started my subtraction. Again, you could do it backwards. You could do negative 12 minus negative 8 and end up with a negative 4 on the top and then move it down. That's fine. Here I'll do t to the 4th minus, so 4 minus negative 16, that'd be 4 plus 16, that's a 20. And that's going to stay on the bottom. Do you want to see something neat that we could have done? What if from the very beginning, again, there's a lot of ways to do these problems, we could have worked in the parentheses first. K cubed over k squared is k. T to the 4th over t to the minus 1 is t to the 5th, because you subtract those exponents. 4 minus negative 1 is 5. Then if you take all that to the negative 4th power, that's going to have you do 1 over that to the 4th, which would be k to the 4th, t to the 20th. It's the same answer. Lots of different ways to think about these. Okay, we have done so many problems, and we did them in 26 minutes, plus 2 long breaks where you went and read the textbook and filled in those notes like you're supposed to, right? Okay, I hope this was helpful. You'll find a homework assignment for you to try. Thank you very much.